Hello, my name is Zach, and I am here with Mitri. I'm showing our Type C Goniophotometer, which you can see right next to me here. A typical Goniophotometer is designed to measure the spatial information for photometric and radiometric quantities. I will go in this video. The goal is to go over the main features of our Goniophotometer and go over how to run it. So I'm just going to start with a couple features here, and then later, while it's actually running, I'll talk about the theory behind it. So above me here, you can see our luminaire, which is mounted in the mounting system. We have a bunch of different type of mounts that can mount anything from your typical light bulb to a street lamp to a floodlight. Above that, you can see our near field detectors. On the left, you can see the photometer. In the middle is an aluminum spinner, and on the right is the photometer. And then right next to me here, you can see the mirror, which is designed for the far field detectors. The far field detectors are the same things. So it's a photometer, a spectral radiometer, and a luminometer. And you can see them right over there on the far side of the room. And then back over here, another feature that our Gonio consists of is an alignment laser. An alignment laser is designed such that it is easy to place the luminaire in the photometric center of the Gonio, which is important for calculations when our software is actually doing calculations of other quantities. And then our last feature, or here I can show you the alignment laser real quick. We have it mounted up on the wall over here, and I can turn it on. And then on the far wall, you can see the crosshairs of the laser, which the crosshair is actually missing because we have a light in the photometric center right now. And then the last feature we have is a screen over here, which will show all of the electrical properties of the light, or at least the basic electrical properties of the light. So voltage, current, power, and the power factor. It will show the current position of the detectors. So we have the A axis and the C axis. And then it will show information about the room. So we have humidity and room temperature. And then just below it here, we have the switches that turn on the Gonio and the power supplies. Next, I'm going to start the Gonio and show you it running and talk about the basic theory while it's running. Thank you. Behind me, you can now see that our Goniophotometer, the GO-R5000 is running. And while it's running, I'm going to talk about the theory a little bit. So as you can see, we are currently in the dark room, which consists of everything, for the most part, is either painted black or covered in a black velvet sheet. The purpose of that is to reduce any stray light that's in the room. During an actual test, we would have all the lights off and no one would be allowed to enter this room. But for demonstration, we have the lights on. You can also see that attached to all of our detectors are baffles. So the baffles will further reduce any stray light from entering the detector, which stray light can greatly affect your measurements, as the goal of the Gonio is to measure all the spatial information of the light source. Getting additional information from things that are not from the light source the detector can't know what is from the light source and what is not, so you have to remove everything that's not. You can also see here that our rotating mirror is covered in a black velvet sheet. That's to prevent light from bouncing off the mirror and entering the near field detectors. So you have to do the measurements for near field and far field at different times. Other than that, we have near and far field detectors. The reason for that is that the near field detectors provide a more accurate absolute measurements, while the far field detectors provide better relative measurements. So the relative measurements are used to create the 3D mapping of the light source. For the theory, that's about it. There's also, so the far field detectors have to be some distance away from the Gonio. LM84 says that, CIE LM84 says that it has to be at minimum 5 times the longest dimension of the light source away, and in some cases 10 times. The reason for this is so that the light source can be approximated to a point source for the far field detectors. And that's about it for this. In the next part of the video, I will show you how to operate the Gonio and our software, and an example test report that would be printed out after the measurements are taken. Thank you.
Okay, this is the last video showcasing our Goniophotometer Type C, the MGO-300R. As you can see, I have a video camera in the darkroom with the Gonio, and it is dark other than the luminaire or lamp that I have mounted in there. It is a down light, so when we take the measurement, we should be able to see that in the distribution. So I'm going to open, I already have it open, so I'm going to switch to the GO-meter software. And this software is the same for all of our Goniophotometers, so it is important to check that the right Gonio is selected, which here it is. And it is selected. I'm going to look at the system startup. It is online, and our detectors are also online, so that's good. I'm going to hit OK. You can see that I'm currently using port 9, which is the default port. And now let me go to control. So this here I can set a lot of different things. So I can move my detectors to any position that I want. Right now it is at the 220, which offsets it a little bit, as you can see here. That's so that you can stand below the luminaire and not have the arm in the way. And if something were to happen, we usually leave it in this setting so that if for whatever reason we mounted the luminaire poorly and it fell, then it's not going to fall onto either the mirror or the detectors. So I'm going to go back here. You'll see that I can also move the arm relatively, so it'll just move in whatever direction by that many degrees. And this is important. Every time you use the Gonio, you have to be sure that the mode is in follow detector, hit modify. Okay, so I'm good here. Under tools, we have our AC and our DC power supply. I'm using a LED with a driver, so it's AC. It's a standard voltage and frequency for the United States, and it's already powered on, so I'm not going to click on that. Okay, so now I'm going to do a basic measurement of our LED. So the first thing, I'm going to go operation. I'm going to go to detector 2. Here it will ask for the first detector. It's going to do 2 measurements. It's going to do the far field and the near field, and it's going to do the near field first. So I'm going to hit select. Okay, so this is asking me for the calibration, which we just calibrated this last Friday. So here it is. And I'm going to hit OK. I'm going to hit OK again. Okay, so here we can set test information. The manufacturer of, well, the lamp isn't going to be true. It's going to be, I'm not sure, it's just a demo lamp, so I'm going to leave it blank. Zach Small, and the operator, so I'll leave that alone. This is the date. The distance is what our Gonio is set to. The remarks, downlight demo, I'm going to keep that the same. Basic electrical parameters are here. The type, that just dictates what type of information it will show you at the end of the testing. So indoor is fine, it's an indoor lamp. Temperature and humidity. The Gonio actually has a built-in temperature and humidity gauge, so if I hit communicate, or COM for short, it will tell me what the temperature in the room is, which is 22.3, and the humidity is 54.5. Now, for standard LM79 testing, the temperature actually has to be 25 plus or minus 1. So this is too low, like this would not be LM79 compliant. For this measurement, which is just a demo, I actually don't care very much, but if I were doing an actual measurement or test, then I would have to turn on the heater in the room and get it to within 25 degrees. And the humidity just has to be below 60, so this is actually would be okay. Other than that, I can put the name, the type, dimensions, whatever I want. I actually don't know what they are, so I'm going to leave that blank. And the lamp type, also, that's fine. So I'm going to hit OK. It's going to take me to my test parameter page. For a typical test, we do a C interval of 10. The C interval is the rotation of the lamp. So the lamp will rotate in place. It's hard to tell with this one because it's a circular lamp, so you can't really tell that it's rotating, but that's important for the test. The C range is 0 to 360, that's pretty typical. Gamma interval is 1, also pretty typical, and the range is 0 to 180. Before I start the test, I want to show you that up top here, I have the distribution, the table, which will show me my measurements, the 3D page. So this is interesting. If I change, that's weird. If I change my thing, it will change the display. So each of these lines is a set of measurements that will update as the test goes. And then the last page is just the electrical parameters. So everything looks good to me. I'm going to hit go. You can set the speed as well. For the demo, I'm going to use high. Speed really depends on the size of your luminaire, which for this one, high is fine. So I'm going to hit start. It's going to ask me a couple more things. I'm going to set reset before testing, reset after testing. So that's going to change. The reset position is with the mirror directly below the lamp. So before the test, it's going to move to there, and after the test, it's going to move to there. I'm not going to use the auxiliary detector, and I'm not going to steady because this is just a demo measurement. Typically, LEDs take some time before they're in a stable position, and in this software you can set that and it will monitor the LED, and you can set a specific time, so like 10 to 15 minutes is fairly standard, but I'm not going to do that today. And then the luminaire direction is down in our case. Hit OK, and the test has started. If I look here, let's look at it move. So as you can see, the mirror is going to, or the arm is going to its reset position, which is just below the luminaire. And then it's going to start taking up. Okay, so the system, as I mentioned before, while the near field test is being performed, the mirror has to be covered, which as you can see in the video, it is. So I'm just going to hit OK, and it's going to start the test. So here is the amount of time that it's taken. We can also look at, if I click on it, how much time is remaining. Now this remaining time is not always accurate. Actually in this case, I think it will be about 30 minutes, but I would take that number with a grain of salt. So here's how long it's going to take. Let's go look at the video. As you can see, it's moving around, and it's begun taking measurements. So this screen will update, and in a moment I'm going to pause the video and then restart it and show you it updating, but it takes a while to go. So I will be right back. Okay, so the first set of measurements has been taken. You can see that one of these white bars has disappeared, and in its place is the color-coded measurement of the luminaire. So the color code has to do with color temperature. So blue is the most intense, and going towards red is the least intense, which you can see that in this little diagram, the blue square is the luminaire, and the line is dictating the direction that it is projecting light. So we have light that's coming out of the luminaire in this direction. Okay, and there's the second test that just updated. And we'll be right back when it's done. Halfway through the test, it's going to prompt me to remove the mirror mantle, and which is that black velvet sheet, and to start the far field testing. And we will restart the video then. Okay, so my measurements for the luminance, flux, and intensity have completed. At the end of the test, it prompted a save as screen, which looks just like your typical save as screen, like this one. I saved it as demo lamp. And I exit here. Up here is the data that I could have entered, or the information that I could have entered before, and then below is the photometric data and the electrical parameters. So as you can see, we have nominal lux, flux, total flux, intensity, the LQ, the LOR, sorry, and so on. If I choose, I can still enter in this information. So if I go to view, test information, I can say luminar name, I'll name it demo lamp, type, downlight. I can keep going if I wish, but that's enough for now. And I'll hit OK. Oh, I can also change what type of lamp it is, which will change the information that it shows me. So let's say it's just a lamp. I hit OK. It removes a lot of the information that I had before, which is fine. Although I'm going to go back to my indoor lamp. Test information, indoor, OK. Bring it all back. Okay, so the next tab I have is the 3D distribution, which is all down light, so that agrees with what we would expect. The purple direction is down in the Z. If we go distribution, it's just the 2D distribution, and isocandela diagram, plano isolux diagram, zonal luminous flux information. This is just in table form. Another isolux diagram, and coefficients are used for calculations, luminance, limitation curves, and that's about it for the luminance, flux, and intensity measurements that our Gonio has taken. I'm now going to show you how to take the color measurements using the spectral radiometer. So you do that by going to Operation, Measurement, Spectral Radiometer. Says please cover the mirror with the mantle, or oh, that's because I'm in near field. So I'm going to choose far field, and it'll say please remove the mantle of the mantle of the mirror. If I go look at my video, you will see that it is indeed removed because that was the last measurement I took. I just used far field measurements. I'm going to hit OK. It'll bring me to my test information screen. This is all the same as before, so I'm just going to hit OK. Okay, so this is my testing parameter screen. This time for C interval, I'm going to use 90 because color information typically isn't as distribution dependent. So this will make for a faster test. So 90, I'll do gamma interval of 10. 0 to 90 will just be the down light, which would be fine, but I'm going to choose 0 to 80 anyway. If we look at the 3D here, you can see that it's going all the way around the lamp. If I were to do 0 to 90, it will be just below the lamp. And then I will hit start. So this is the same as before. Hit OK, and my test has started. So I've actually already performed this test, so I'm not going to wait for it to do it again, but this is the same as before. So I'm going to pause it. I'm going to exit it. It's going to prompt hit yes. So stop after current scanning. Yes, it will stop, or no, it will reset the system and then try again. But we're just going to hit yes. Cancel. Yes. Exit. Thank you. Okay, so I'm going to open up. Well, actually, I have to go spectral radiometer, color data view. I'm going to open demo lamp 2. So here I go. This is my curve, gamma angle down here, color temperature over here. This is one of the several information views that I have. I can do table, so it just shows me at what position the lamp and detectors were at, and then the actual information in here. So I have intensity, color temperature, or color coordinates, I apologize, color coordinates, color temperature, general, CRI, again, color coordinates, SDCM, and then the same over here. So, and then IP numbers, but that actually won't do you a lot of good unless you know the total as well. That's just for the software itself. So, and then I also have a spectrum view, 3D view. The 3D view is not as useful here because I didn't take as many measurements, so I don't have as complete of a mapping. And then I also have access to statistical information. So if I go to view statistic, and then here I have the average, gives me the color coordinates, or CIE coordinates, color temperature, general CRI, where it fit in the white class over here. I have a couple different white class presets, so that's the information displayed here. So I'm going to exit. So that's about all for this video. This was for the GO-300R Goniophotometer. It is a Type C rotating mirror, so it is LM75 and 79 compliant. Our software is capable of exporting all this data into either Excel or into more typical IES testing data forms, or missing a word, file types. And that is about it for this video. So thank you for watching. If you have any questions, please feel free to direct them to me at zachs@mitru.com. Zach is spelled with an H, so it's ZACHS@mitru.com, or feel free to call us here at the office. I will put the phone number in a citation. So thank you for watching, and have an excellent day. Bye.